Hello friends, myself Ganesh Borhade. In the last lecture studied about the pin diagram and pin function of IC741, that is the operational amplifier, right? Now in this lecture, what is the block diagram of the op-amp and function of each block? Okay, then start the topic. This is the block diagram of operational amplifier. In last lecture studied the what is the operational amplifier, means the many operation like addition, subtraction, multiplication, division, means the arithmetic operation can be performed by using the IC741. Therefore it is known as the operational, and mainly it is used for the amplification purpose, means which convert low signal to the high signal, right? This is the block diagram of the operational amplifier. Means there are the various blocks used in the IC to perform the operation. Right? In the block diagram, this block diagram shows there are the four block: input stage, intermediate stage, level shifting stage, and the output stage. The input stage having two input, that is the inverting and the non-inverting input, right? This input stage is the first stage of the operational amplifier. Let's see the function of each block. First stage is the input stage. The input stage is known as the dual input balance output differential amplifier stage. Why this stage is known as the dual input and balance output? Because this stage having two input and two output. Therefore, this stage known as the dual input balance output. And this stage having two input, one is the inverting and another one is the non-inverting, and it provide high voltage gain and decide the what is the input resistance of the op-amp. Means this stage is also known as the gain stage of the op-amp, because this stage decide the gain as well as the input resistance of the op-amp. Then second stage, the second stage of the op-amp is the intermediate stage. Intermediate stage. Okay. The output of the input stage that is applied to the intermediate stage. This is the second stage, and this stage is known as the dual input unbalanced output differential amplifier. Why this stage known as the dual input unbalanced output differential amplifier? Because it having two input and one output, means that is the unbalanced two input and one output. Therefore this stage is known as the intermediate stage, and it is the another differential amplifier. What is the meaning of differential amplifier? The differential amplifier means it amplify the difference between two input. Therefore this stage is known as the differential amplifier, same as the input stage. Okay, then next stage, the next stage of the op-amp, the next stage of the op-amp is the level shifting stage. Level shifting stage. Okay. The level shifting stage. This stage does not provide any gain. When this stage does not provide any gain, only adjusts the DC level to the 0. Then what is the function of this level shifting stage? Due to the due to the direct coupling between the first two stages, that is the input stage and the intermediate stage. Direct coupling, the output of the intermediate stage, the output of the intermediate stage having AC as well as the DC signal, AC as well as the DC signal. But we want only the AC output. Therefore, to reduce the DC level, the level shifting stage is used. What is the coupling? Coupling means there is the coupling element which are used in between the two stage. The coupling element are the resistor and capacitor. What is the function of capacitor? Capacitor is always pass the AC signal and block the DC signal. But here there is no any coupling element. Due to that, what happen? The input of the level shifting stage having AC as well as the DC signal. But we want only the AC signal. Therefore, by using the level shifting stage, reduce the DC level with the 0, right? Means the level shifting stage is used to bring the DC level to 0 volt with respect to the ground. This is the function of level shifting stage. Remember, this stage is known as level shifting, means which shift the DC level to the 0. It does not provide any amplification. Then the last stage is the output stage. The last stage is the output stage. This stage is complementary push-pull amplifier stage. Means in this stage there is one input and one output, but the input is applied to the simultaneously applied to the two transistor. Depending on that, these two transistor conduct alternately. Means if one transistor in conduction, then another transistor out of conduction, and this stage increase the magnitude of voltage, means it provide the high gain and rise the current supplying capability of the op amp. If the current supplying capability increases, obviously the output voltage increases, means it provides the low output resistance. This output stage provide the low output resistance. Okay, this is the function of the different stages of the op amp. Then the next part is the circuit diagram of each stage. How this input stage, intermediate stage, level shifting stage and the output stage work. The first stage is the input stage. The input stage having two input. One is the Vin plus, means that this is the non-inverting input, and another one is the Vin minus. This is the inverting input. Both the input apply to the base terminal of the transistor Q1 and Q2 and take the output at the collector terminal of the transistor Q1 and Q2. Means it having two input, one is the non-inverting, another one is the inverting, and the two output. This output is applied to the next stage. This output is applied to the next stage, that is the intermediate stage. Remember, the input stage having two transistor, and these two transistor operate in the common emitter configuration, right? And take the output from the each collector terminal of the transistor and apply to the next stage. Therefore, this stage is known as the dual input balance output, and this stage provides the most of the gain and decide the input resistance of the op-amp. Remember, the input resistance of the op-amp is always very high. In practically, it is 2 mega ohm. Okay. Then the next stage is the intermediate stage. This is the circuit of the intermediate stage. This is the another stage of the differential amplifier, means which amplify the difference between two signal, means the output of the input stage applied to the intermediate stage, means it having two input but there is a only one output, means the output is taken from collector terminal of transistor Q1 or Q2, either from Q1 or Q2, means it having two input and one output. Therefore, this stage is known as the dual input unbalanced output differential amplifier stage. Why this stage is known as the dual input differential amplifier? Because it amplify the difference between two input signal. Okay, this is the circuit of the intermediate stage. Then the next stage is the level shifting stage. Level shifting stage. This is the very important stage because if there is absence of level shifting stage, then output having AC as well as the DC signal. But we want only the AC output. Therefore, to reduce the DC level, use the level shifting stage. It is the emitter follower stage. It is the emitter follower stage. Why this circuit is known as the, or why this stage is known as the emitter follower stage? Because in this stage, in this circuit, take the output from the emitter terminal of the transistor. At the input side, see, there is a DC as well as the AC signal. Why there is a DC or DC and the AC signal? Because in first two stage, means the input stage and the intermediate stage, there is no any coupling element. Due to that, what happen? The input of the level shifting stage having DC as well as the AC signal, means the signal is shifted from the zero, right? Means there is a DC as well as AC signal, sinusoidal signal, right? And when apply this signal to the input of the transistor, means the base terminal of the transistor, and take the output to the emitter terminal of the transistor, use the voltage divider rule, and by using this technique we get only the AC output, means this stage reduce the DC level to the zero, right? This is the function of level shifting stage. Then this is the last stage of the op-amp, that is the output stage. The output stage is known as the complementary symmetry push-pull amplifier stage. Means in this stage use the two transistor, and these two transistor conduct alternately. Means if one transistor in conduction, that time another transistor out of conduction, right? And this stage provide the most of the gain, and having this stage provide the low output resistance. Due to that, what happen? The current carrying or the current supplying capability increases. Therefore, we get the maximum amplified signal at the output. This is the waveform of the output stage. See here, if one transistor in conduction means on, that time another transistor off, right? Means these two transistor conduct alternately, right? Therefore, this stage is known as the complementary symmetry push-pull amplifier stage.